This is the lecture video for section 6.2, video 3. Here we're going to solve trigonometry equation using quadratic formula. So the example we have is we want to find all solution for cotangent of x times cotangent of x plus 3 equal to 1. So we're going to use the quadratic formula. The quadratic formula is when we have a quadratic equation ax squared plus bx plus c equal to 0, then we can find the answer for x using the formula of negative b plus or minus square root of b squared minus 4ac over 2a. So in order for me to use the quadratic formula, I first need to have written down my equation into the standard form. So I'm going to multiply the cotangent of x into the cotangent of x plus 3. So I got cotangent squared of x plus 3 times cotangent of x equals to 1. Not quite equal to the a times x squared plus bx plus c equal to 0. So I also need to subtract the 1 to the left side. So I end up with cotangent squared x plus 3 times cotangent of x minus 1 equal to 0. In order to use the quadratic formula, I need to figure out what is my a, b, and c. The one thing I need to point it out is here we still have a quote-unquote quadratic equation, but the x we have before is going to be replaced by trigonometry function. For this case, it's going to be the cotangent of x. So we can see that from the cotangent squared of x, that is corresponding to our x squared. So our a is going to be 1. 3 times cotangent of x is corresponding to our 3x. So b is going to be 3. And then negative 1 is corresponding to our c, so c is negative 1. Then cotangent of x will equals to negative b plus or minus square root of b squared minus 4ac over 2 times a, where b is 3. A is 1. And then c is negative 1. So simplify them. I got negative 3 plus or minus square root of 9 plus 4 over 2, which is equal to negative 3 plus or minus square root of 13 over 2, which is not really close to anywhere. So I got two solutions for cotangent of x. One is negative 3 plus square root of 13 over 2. Another one is cotangent of x equal to negative 3 minus square root of 13 over 2. Now I'm going to punching those into the calculator to get a decimal calculator. We got the first one is approximately equals to 0.3027756377. And then the second one is approximately equal to negative 3.3027756338. So we have those numbers, but that's not equal to x. So I have to continue to figure out which x will give me cotangent of x equals to those two weird numbers. So I'm going to using the inverse function. So x equals to cotangent inverse of the decimal numbers we just got, and then punching them into the calculator. However, since we do not have cotangent in a cotangent inverse into the calculator, so I have to rewrite it into tangent inverse. So tangent inverse will equals to 1 over 0.3027756377, and tangent inverse of 1 over negative 3.302775638. Now we can add it. Now we can punching them into the calculator. 1.276795025 for the first one, and then negative 0.29400130018 for the second one. So just to make it shorter, I'm just going to say 1.28 and then negative 0.29, just rounding up. Okay, so I'm pretty much finished. However, the question is asking for all the solution. So I need to find not one or two solution, I need to find all the solution. So to find all the solution, we know that we are working with cotangent function. Cotangent function has a period of pi. So once I have the inverse function, I got one answer. The answer, I can get the same cotangent value by adding one period. So if I'm just adding a pi to adding a n pi, actually not only one pi, if I'm adding a k pi to the answers, then I have I'm pretty much including all my answers. So combining them together, my answer for the x is going to be 1.28 plus k times pi. Sorry, not n. K times pi. Or negative 0.29 plus k pi, where k is any integer. Sometimes we do not really like how to have a negative answer, so sometimes we actually adding 1 pi to the negative 0.29 to make it a positive number. So after adding a pi 3.14 approximately to negative 0.29, we got about 2.85 plus k pi, where k is any integer, to make it positive. So both are okay. We normally prefer to have everything positive, but both are the correct answer.